Welcome to Going Beyond the Syllabus, conversations inspired by books and powered by experience. I'm your host, Dr. Rohini Abhyankar, and as a new faculty member, I'm personally exploring how to design courses that encourage real innovation. So I'm thrilled to dive into today's topic. This podcast is proudly sponsored by Keen, the Kern Entrepreneurial Engineering Network. This episode is inspired by Tony Wagner's foundational book, Creating Innovators, which argues that the next generation of changemakers won't be shaped by compliance, but by fostering play, passion, and purpose in education. And to help us bring these ideas to life, I'm joined today by Dr. Tony Schmitz. Dr. Tony Schmitz is an accomplished engineer and an educator, holding degrees in mechanical engineering from Temple University and University of Florida. He began his academic career in University of Florida, Department of Mechanical and Aerospace Engineering in 2002, and joined the Mechanical Engineering Department in UNC Charlotte in 2011. He joined the Mechanical, Aerospace and Biomedical Engineering Department at the University of Tennessee, Knoxville in 2019 with a joint faculty appointment at Oak Ridge National Laboratory. In 2025, he was hired by MSC Industrial Supply Company as a Distinguished Technical Fellow. Dr. Schmitz has a proven track record of success in manufacturing research and has also received major accolades for his innovative teaching. Welcome, Dr. Schmitz. We are excited to have you on the podcast.
Yeah, thank you. It's my pleasure to be here and to talk about innovation.
Sure. So, Dr. Schmitz, before we dive into the innovation theory or definitions or details, can you share a little bit about your journey as a teacher and a faculty member? And what was the aha moment that first motivated you to experiment with new approaches in your classrooms?
Yeah, I'm happy to. So I studied engineering, like many young people, because I liked science and math. So that was a natural trajectory in my college career. When I finished, I took a job at a cast iron foundry. And while I enjoyed the new things that I learned, it was clear to me that I wanted to continue learning. So that took me back to graduate school, where it was my intent when I went back to graduate school to have a teaching position when I was all done. And so as I went through grad school, that was kind of how I shaped my education, was trying to learn as much as I could so I could be an effective teacher later. So in terms of experimenting with innovation in the classroom, that happened in large part because I was assigned a course. When I was at UNC Charlotte, there's a 3-year curriculum called sophomore, junior, and senior design, which I think is actually a really outstanding approach to train young engineers. And I was assigned junior design. That's an electromechanical design course, and it's team-based, and I had never taught anything like that. And because it was new to me, I started from scratch. And a lot of times that is the best way to introduce innovation, is when you have to learn something on the way yourself.
That's true. That's so true. So when I was going through your background, I have noticed that you have received major awards for teaching excellence. What did winning an innovative teaching award mean to you personally and professionally? Did it validate your early experiments that you tried with your design courses?
Yeah, I believe it did. Teaching in terms of being incentivized as a young professor is probably not at the top of the list. Young professors feel pressure to generate external funding and graduate PhD students and write papers. And oh, by the way, it would be great if you're a good teacher. And maybe I'm being a little bit facetious about that, but being recognized for teaching was so meaningful because I didn't have as much incentive to be a great teacher as I did to be a well-recognized researcher, but I thought it was so important that I put a significant amount of time into it.
Yeah, that's very true. And there is pressure of all sorts on new faculty and tenure track and teaching faculty. And there's also pressure to be innovative in your classrooms. To dive deeper into the subject, so let's start with a definition. How do you define innovation in a technical classroom? And how is that different from simply doing good engineering?
Yeah, at the time that I was doing junior design, which was 2011 to 2019 at UNC Charlotte. I didn't have the book that we're reviewing, Creating Innovation.
Yeah.
But one of the figures in the book is actually how I defined innovation in the classroom. It's on page 24. It shows a Venn diagram of overlapping expertise, creative thinking skills, and motivation. In the center, where those overlap, is creativity or innovation. And that was actually what I tried to accomplish in junior design and my other courses, where for expertise, it's important to teach the concepts to support engineering thinking, but it helps if those are contextual. If I'm telling you what you need to know for a problem that you need to solve. For the creative thinking skills, you need that expertise in order to assess ideas with math and physics. It's not enough just to say, wouldn't it be cool? It needs to be cool and feasible. And then finally, for motivation, I think the team-based approach is very effective because you get to have play, you get to have freedom within your team where the instructor really isn't necessarily a part of those conversations. And then I framed the course as a competition where the individual teams competed for a top score within some rubric. And I think taken all together, it gave us a meaningful course experience for these students to grow their understanding of engineering and then move forward in their careers.
Mm-hmm. That's wonderful. So you are in alignment with what Wagner has said in his book, with the intersection of the three circles, right? The experience and with creativity as the overlap of all three. So that's true. So could you talk about a specific example, a tangible example of an innovative practice with your students, and what impact did it have on your students?
Yeah, well, I mentioned it a bit already, and I'll come back to it because it was such a terrific 8-year experience for me, was this junior design course. And part of it was just to keep myself engaged and entertained. I changed the project each semester. So, for example, here's some of the projects we did. We did a wall walking robot where they had to have a robot that climbed a wall. Pick and place robots, which were for speed and accuracy. We did a laser pointing robot at random targets, a sketching robot where they had to write and sketch with the robot. And then we did a fishing pole casting robot. That one was a lot of fun. So they had to build a robot to cast the fishing pole, and then we did it for distance and accuracy. And through that project, I added some components. One of those where they pitched their idea to local business leaders. We had a panel who picked what's the most promising pitch. And then we held the competition at the local Bass Pro Shop. So other people got to see what they were doing. So that whole experience, it was fun for me. It was fun for the students. And, we did some good learning along the way.
That's fantastic. On the campus, I see these little delivery robots these days going all over the place. Were any of those made in your classrooms? Just a curiosity question here.
I wish they had. I could speaking to you from a mansion on a hill, but no, they weren't. Okay. But doing similar things. Like we had something we were trying to accomplish, delivering food, and then we used electromechanical design principles to meet that objective.
Mm-hmm. Now, when you are trying these new ideas, what challenges did you face from the students, from administration? Were there any specific challenges?
Well, first of all, I can say for the students, no. Generally, they were excited once they learned about the project and were ready to get going. From administration, no. My efforts were fully supported, and it was understood, right, that this is an important thing that we're doing. The main challenge was me. This is another situation where I found something in the textbook that I thought was spot on. This was from page 161, where they're talking to a teacher about challenges that she faced. And she says, and I thought this was great, you need to have a different notion of yourself and your role here. She's at Olin College. Being the sage on the stage is problematic when you're trying to encourage intrinsic motivation. So you have to take your ego out of this in order for your students to have the freedom to be creative. Because if you have a way that you think this problem ought to be solved, you'll naturally discourage things that deviate from your way. And so I had to completely remove myself from here's how I'd solve this problem, and here's student solutions, and then provide feedback on those.
That's amazing. So that's very true too. Everybody looks at problems differently and solves them differently. So that's amazing. Now, Wagner's book came out in 2012. Thinking about your proudest example, how has technology transformed the way we implement that in practice? Specifically, how have things like AI tools and widely available makerspaces changed the landscape of classroom innovation compared to when you started?
Yeah, so let me begin with the makerspaces. I think students today generally feel like they can make meaningful objects, often by 3D printing, because polymer 3D printing has become low cost and almost ubiquitous. So I think that has changed. When I was an undergrad and I had a design project, I was doing things like a bandsaw to cut things out and just doing my very best to rig things together with what was available to me, which was limited. That's different today. So the makerspace certainly contributes to confidence in being able to take digital designs into physical prototypes. For AI, I think educators probably will have mixed feelings about this. But from my perspective, I grew up through spell checking, and the notion when the spell checker came out is, we're going to train a generation of people not to spell. I don't know if that was true or not, but I don't think the quality of spelling and publications has diminished. So I kind of see AI the same way. It's an assistant in order to let me maybe not do things that are easier to automate and let me focus on things that aren't easier to automate, like innovation.
Yeah. And it's a tool that the students need to learn to use wisely. They have to be able to retain their creativity while using this tool also. So that probably needs to get incorporated into classroom one way or the other.
Yeah, agreed.
Yeah. Now, as you know, this podcast is supported by Keen, the Kern Entrepreneurial Engineering Network. And they propose, there are 3 core principles. They promote entrepreneurial mindset in engineering students. That's their mission. And the founding stones, pillars of that mission are curiosity, connections, and creating value. So those 3 ideas map beautifully into Wagner's book. When I was reading the book, I thought, well, there are lots of parallels between what Keen is doing and what Wagner is proposing. So for the first principle, the play, so let's start with play, and which aligns strongly with curiosity and exploration. So how do you see exploration or experimentation and allowing for failure fitting into rigorous engineering curriculum?
Historically, in the engineering classroom, and this is how I learned, is you're provided with principles, you're given example problems to try to solve, and then you get an exam where you exercise what you've learned. That leads us into this idea that there is a right answer, and if I don't get that right answer, I'm unsuccessful. I think play is important because it stands in opposition to that. Play provides the opportunity for expressing creativity while removing that constraint of just getting the right answer.
Yeah. So if we encourage play, and if a student wants to take time, but they also feel the pressure for the rigorous curriculum, then how should the students be balancing that?
One opportunity is extracurricular activities that are available, like joining the Rocket Club or the Baja team, or some of these other society or competition-based activities that are not constrained like the classroom. There is a challenge that you're trying to address, and you're doing it at a team-based approach. So I would encourage students to go find those activities and get a better balance if they're not finding that right now with what they're doing in the classroom.
Mm-hmm. Yeah, that's a great suggestion, I think. The next principle, Keen's principle, that links to the book is passion. And passion, this is the key to creating value, which is a Keen founding stone over a lifetime. So, how have you been successful in helping students connect with their passion or discover something that excites them the most, especially when, again, in the bounds of the rigorous curriculum?
So let me be a little bit pragmatic about my response to passion. As young people, we're often very idealistic. As an older gentleman, some of that idealism has been knocked off of me. But I'm not talking about passion in terms of how am I going to change the world. Let me talk about passion in terms of how can I go to work every day and be excited about what I do. So I think for that definition of passion, this team-based learning is very valuable because it lets you try different roles within a particular project. Like I've seen students who at the beginning of the semester will emerge as kind of a team leader and project manager. And by the end of the semester, feel like I don't ever want to be a project manager again. I did not enjoy that. Or maybe they did. Some others might assume the programming role because they know the programming language or an integrator. And so I like this notion of let me try to be this persona within a project. And then I can decide, is that the right fit for me in my career or is it not?
Mm-hmm, mm-hmm. Okay. And then the last one that I want to establish a link between the two, what Wagner is saying and Keen's foundation stones. So that is purpose. So a purpose about it links directly to making connections and learning in the real world, which requires making connections across disciplines most of the time. And these days, everything is interdisciplinary. So what strategies have you used to help students see the why behind their technical work?
Yeah, that's such an important topic to address because every student at some point in his or her academic career will say, why am I learning this? Why am I in this course? From my perspective, I think design projects work very well because what you see in those projects is the chance to observe how the fundamental concepts that you've learned enable you to make good design decisions. If you're not using good math and physics in your design decisions, your project may fail. And that's okay, right? That's a learning opportunity too. But if you have applied those concepts and you get a successful project outcome, the why is self-evident.
Yeah. And you did talk about mostly your classes were design projects and they were all hands-on. So the project-based learning, what are your thoughts on project-based learning that's promoted every day these days?
Yeah, I guess if Tony were in charge of the world and we're designing academic curriculum, that's how I would design it. I think contextual learning, particularly math. I learned my math completely separated from any engineering support or any application domain. It was calculus 1, 2, and 3, and then differential equations. And by the time that I had to apply those math concepts in models, I'd largely forgotten what I learned and had to relearn it. For me, it would have been so much more efficient to learn those concepts at the point of need. And I think a carefully constructed curriculum that integrates math, physics, chemistry, all the things that we kind of learned in a vacuum within projects is a different way to learn. And I think could be very enjoyable and effective.
So maybe Tony gets to be in charge of the world pretty soon. Because that's how I see it, but I also see the constraints on the other side. So, yeah.
Yeah, of course. And my wife would probably say, there's no way Tony should be in charge of the world. Just
yeah. All right. So reflecting on all these things that we're talking about, innovation and passion and creativity and curiosity. So is there one specific story from your teaching that perfectly captures the spirit of innovation? So a moment when you saw students light up or when something truly clicked with them?
Yeah. You can see that light bulb moment many times, even in a traditional curriculum. If you see a solution to a differential equation and it makes sense, and you can see the student click, that is wonderful. But from the design teaching perspective, I do have an example. For the semester that I did the fishing pole casting robot, and that was a very difficult project to do in one semester. We used the Arduino microcontroller to control their motors. And so, they had to automate this thing. And within one semester, I had one team that figured out how to communicate with the Arduino from their smartphone. And this was quite a time ago, before everyone was on their smartphone all the time. In the same semester, I had another team that used a cooler and dry ice to keep their Arduino cool, which increased power and extended its life. So I found great value in these moments when the students expanded beyond what I could have imagined when I assigned the project and did things I didn't even think of. That was the innovation moment for me when I saw, this is what I thought was going to happen, and it just got much bigger.
Oh, wow. Wow. Okay. So it's bidirectional learning or experiencing innovation. That's
good point.
Yes. We talked about Wagner's book coming out in 2012, and this is 13 years later. Despite all the changes, the systemic barriers such as teaching loads and assessment systems are all still with us. So what's the biggest challenge to foster innovation in higher education that hasn't gone away?
Well, we do have pressure to graduate students in 4 years. And so we have a curriculum that satisfies that. And we need to balance some liberal arts component with their engineering components. And so there's not a lot of room for deviation from this is what you must do in these 4 years to get done. And I'm not sure learning, at least in my own personal experience, is well aligned with you must learn at this pace, at these times. And so I don't have a solution for that. I understand accreditation. I understand the need to assess. But, I think we have to allow students these pockets of exploration and learning time that might be not well aligned with the goal of getting them out in 4 years with these courses finished. So it's a tension. I think if we're just aware of it as the boots on the ground, as the teachers in the classroom, we need to be the ones to provide that because there is this framework in which we must exist today.
Yeah. And some questions persist. That is true. And that is why we need to be at it, as you are saying. So that is correct. When we thought of this podcast idea and to base it on a book, we distributed books to our engineering faculty here, and we had invited questions. So as we are approaching time of the allocated time for our podcast, I'm going to take a couple of questions from our listeners. Our listeners often struggle with institutional pressure, and you have accreditation, research demands, and standardized outcomes. Where do you find the balance? So we did touch upon it a little in the earlier question, but what's the non-negotiable principle you keep when the system pressures you to compromise on innovation?
Yeah, from my own perspective as a teacher, the way I approached how was I going to use my time in the classroom is that when a student left my course, if one of my peers talked to that student and asked them questions, there are things that I felt like those students should be able to answer. And so from my own personal integrity, what I wanted to make sure is that I did my very best to enable those students to speak with someone that I felt like was an expert and be able to hold their own in that conversation. So that is a daily activity. Each time I'm with the students, I want to try to take them at least one step further along their path in becoming a well-rounded engineer. If I do that every day, then I felt like the larger outcomes would take care of themselves.
Okay. Here is another reader question. If a faculty member wants to implement more collaborative hands-on projects, how can they fairly assess individual student contributions while still encouraging genuine teamwork? What metrics do you use to evaluate innovation skills versus technical mastery?
Teamwork, right? How do you assess teamwork? Good grief. The strategy that we used in junior design, and I didn't come up with this framework existed when I took over that course was peer review. And it was anonymous peer review of each team member of all the other team members. I taught that course 17 times. And what I found was the peer reviews were almost uniformly fair. And if a student had a poor peer review from his team, it usually was not a personality thing. It was because the student didn't show up, didn't do the things he or she needed to do to support the team. And I felt like that was a very effective assessment. It is fraught with potential for personality conflicts, but I just didn't find that to be a problem. I felt like students were fair, and it gave me meaningful feedback.
Okay. And to get to a very tangible takeaway from our conversation today. So if for a faculty member listening right now, if they only had 15 minutes today to try one thing in their class, what tiny change could they make to embody one of Wagner's 3 Ps?
Yeah, I think for all 3 of Wagner's pillars, it is humility as an instructor. As we go through our master's and PhD programs, we are supposed to exhibit that we have deep technical knowledge and expertise in an area. And that leads us to kind of be, as I mentioned from the textbook before, the sage on the stage. I have the information. I'm going to give it to you. If you listen, then you will learn. I would say, if you want to do one thing, approach your classroom time with a level of humility that lets you say, oh, that's a good question. I don't know, but let's go figure it out. And letting student questions drive some of your activities that may be outside your comfort zone is challenging, but it will give that classroom environment that you want that fosters creativity and innovation.
Okay. So is there something that you would like to say, which I haven't already asked you, something to the listeners, something that's on your mind, advice, information, pointers, tips that you can think of that you would like to share with us?
Yeah, my research area is manufacturing, and I've spent a long time in this area. And when I began, it was when offshoring had already begun, and much of the daily manufacturing activities were being completed in countries with lower labor rates with the intent of retaining innovation here in the US. And, I think that's a flawed concept, and we're trying to recover from that mistake today. And so here's what I would say. I think there's a push now saying, universities and colleges are very expensive. In order to join the manufacturing field, you don't need to worry about that. You can go work and be successful and provide for your family. All that is good. But what I would hate to be lost in that narrative is a lifetime of learning. I can say that every day I try to learn something new. I've never arrived at the point where I think, oh gosh, I know enough now. That is not true. I don't think that's true for anyone. And so lifelong learning would be my takeaway from this. I think that opportunity is provided by a university or college education. And so I would encourage it. But even if that's not your choice, take the opportunity each day to learn something new. And I think that's the very best way to advance your career.
Dr. Schmitz, thank you so much for sharing your insights and experiences. Your examples not only bring Wagner's message to life, but provide a practical roadmap for us all. So thank you.
Well, thanks for the opportunity. I enjoyed it. I enjoyed the book, and I look forward to talking with you more.
Sure. And to our listeners, if you are inspired by this conversation and want to learn more and want to bring the entrepreneurial mindset into your classroom, be sure to visit engineeringunleashed.com. That's the resource platform for the Keen Kern Entrepreneurial Engineering Network. That's the easy way to bring it to your classroom. Thank you for joining us on Going Beyond the Syllabus. I am Dr. Rohini Abhyankar, inviting you to keep experimenting, keep reflecting, keep going beyond the syllabus. Until next time.